Okay, have a look at page 9. We have last two pages, page 9 and page 10. Have a look at page 9, example 2 first. Okay, have a look at page 9, example 2 first. Okay, let's think about how to solve equations. Okay, how to solve equations. Okay, for log 2, 6 equals to k times log 2, 3 plus 1. And you're solving for k. So what I can have is k log 2, 3 equals to log 2, 6 minus 1. Okay, let's say just minus 1. And that is k equals to log 2, 6 minus log 2, 2. Okay, 1 is log 2, 2. I want to make it to the same base. And then that will divide by log 2, 3. That will divide by log 2, 3. And k equals to log 2, 6 minus log 2, 2. So it's log 2, 6 divided by 2. You will have log 2, 3 on the top and divide by log 2, 3. And k just equals to 1. A just equals to 1. Okay, so you will try to simplify as much as you can. If you leave your answer as log 2, 6 minus 1 divided by log 2, 3, you may lose mark because it's not the simplified form. So when you subtract any constant, try to make it to the same base as the previous number and then have a think whether I can simplify or not. If I can't, just keep as that. If I can, you need to simplify to the simplest form. Okay, the next one is 3 to the power of 2x minus 1 equals to 28. You have x on the power, okay? You have the x on the power. So you solve for power, you need to use log. So 2x minus 1 should equals to log 3, 28. Log 3, 28. And then you have 2x equals to log 3, 28 plus 1. So plus 1, I can say that's log 3, 3 plus 1. So x equals to log 3 times 28. 84 divided by 2. Okay, 80. Log 3, 84 divided by 2. Well, I can say that's a half. I can say that's like a half times log 3, 84. So I can write it in this way. Okay, square root of that number. So this can be write into a half times log 3, 84. And I can put this a half back onto the power, which is square root 84. Well, 84. 84 is 4 times 21. So 2 root 21. Okay, 2 root 21. But let's say it's not really necessary to simplify to this form. Like I can just simply write my answer as x equals to log 3, 28 plus 1 divided by 2. This is also nothing wrong with it. Okay, I can also write as log 3, 28 plus 1 and then divide by 2. It's also alright. Okay, because your simplified form is not really looks better than that one. So they're not necessary, but it's good to see all of these workings. Okay, how just be careful with the number can be put back to the power. This is actually a very useful property. Okay, the number can be put back to the powers. That's a very useful property. Okay, that's when we solve for equations, exponential or logarithm equations. And if I can go up to example 1, let's have a think about how to solve all of these inequalities. Okay, how to solve all of these inequalities. Just remember, to solve inequality, make sure you want your base to make all the base to be greater than 1. What means my base greater than 1? Say some number, if you can put the base as a third, or you can put your base as 3, you keep your base as 3. Don't put your base into a third. Okay, that will make a difference. That will make a difference. Let's have a look, just for example, this question. You have 3 and 27. You know your base can be 3 or can be a third. So now I want to make the base to be 3. So this side will stay the same. 3 to the power of a half x plus 1. Greater than, that will be 3 to the power of negative 3. 3 to the power of negative 3. Okay, if your base are the same and also your base is greater than 1, you can directly put your power as this relationship. Okay, because if you have 3 to the power of x, this graph will look like this. Okay, the larger the x values, the higher the y value. So you want a larger number on the left hand side, which means the power needs to be larger than the negative 3. Therefore, I can just solve for that. A half x is greater than minus 4. X is greater than minus 8. Well, let's think about example 2. Example 2, 0.7 and 0.3. I can't really put them into the same base, right? You can't. So let's just not do this question first. Let's have a think about the later on question. Like that's 2 types of questions, okay? So when you solve inequalities, one type is you can make the base to be the same. The other type is you can't make the base to be the same. So if you can make the base to be the same, you solve by this way. If you can't, you use log to solve for it. But let's not talk about it at this moment. Let's finish the other 3 first. So for the next one, you have 3 and 9 as your base. So 9 can become base 3. 9 can become base 3. So that's 3x minus 7. That's 3 to the power of 2 times minus 2x plus 8. Same base, greater than 1. I can directly write the relationship for the power. Okay, 7x greater than 27. 23, not 27. Okay. And your x will be greater than 23 divided by 7. Okay, example 4. One side is 2, the other side is 1 on 16. Base 2, okay, obviously base 2, 2 to the power of minus 3x plus 1, less than 2 to the power of negative 4. Okay, it's 1 over 2 to the power of 4. Therefore, it's 2 to the power of negative 4. And then I will have negative 3x plus 1 less than minus 4. The left-hand side's power needs to be less than right-hand side's power. Minus 3x less than minus 5, subtract 1 on both sides. X will be greater than 5 over 3. Okay, you divide negative 3 on both sides, the sign needs to be swapped, so it's greater than 5 over 3. Okay, next one. Next one, you have 1 over 3 to some power and less than or equals to 27. Then power, like base needs to be 3. For this side, if your base wants to be 3, so that's 3 to the power of negative 4x plus 2. Okay, the negative of that power. Less than or equals to 3 to the power of 3. Then you have 4x minus 2 less than equals to 3. 4x is less than or equals to 5. X will be less than or equals to 5 over 4. Okay, all of these 4 questions we did is all the same type. Okay, they're all the same type. It's same as when you, like, it is quite similar to when we're trying to solve equations if there's an equal sign. But like the difference is if it's an equal sign, we don't really need to make it to the base greater than 1. I can make both sides to be base a third. Like if it's equal, it doesn't really matter whether the base is greater than 1 or it's in between 0 and 1. But if it's for inequalities, like I would say just make it all greater than 1 and it makes it a little bit easier to calculate. If you make base is a third, then the power will be in the negative relationship. Because if you think about a third to the power of x, your graph will look like decreasing graph. You want a higher y value, you need a less power. Okay, you need a less power. So therefore you need to swap the sign when you talk about the powers, which like just cost a lot of trouble. So you may forget or something like that. So just make it greater than 1. So let's have a look at the second type. So to solve inequalities, one type is both sides can be the same base. Also, base needs to be greater than 1. Second is base cannot be the same. We will use log. I'll always use log a base greater than 1. Okay, log base greater than 1. I'll say like you can always use log base e. Okay, always use log base e, which will be definitely correct. Sometimes it's a little bit difficult to calculate by that way, like just do more workings, but it definitely will be correct. Okay, it definitely will be correct. Let's have a look at this. So left-hand side number is less than right-hand side power. So if you log e both sides, if you log e both sides, okay, what's log ex looks like? That's log ex. Okay, that's log ex. Okay, so the larger the x values, the higher the y value. So your left-hand side number is less than right-hand side number. So your log will be less than as well, because log is an increasing function. The higher the x values, the higher the y values. So this number is less than that number. When you put it, substitute into log e, the whole log e will be less than 4 log e for that. Because say that number is about here, 0.3 is here, that number is here, so the 0.3 will be higher. Okay, 0.3 will be higher. So let's draw this here. Okay, if your 0.3, say 0.3 is here, and then you will have 0.7 is here. Okay, that number is 0.7 minus x plus 1. It's less than 0.3. You don't know where is it, but it's definitely less than 0.3. So the y value for that one is less than the 0.31. Okay, so when you log both sides, that sign will still maintain the same. But remember, it must be log a base greater than 1. If it's log 0.7 something, you can't work in this way. Okay, so you always use log base e. Always use log base e. And we can solve this easily. Log E7 and then to a power. This power can be bring down. So that's minus x plus 1 times log E 0.7 less than or equals to log E 0.3. And I want to divide log E 0.7 on both sides. Divide log E 0.7 on both sides. What's the sign should be here? Should we change sign or not? Okay, at what case do you change the sign? Negative, right? Negative. You divide the negative number. Let's have a look. What is log E 0.3? What's this value? What's this point? 1, 1, 0. Where is 0.7? To left. Do you have a negative value or positive value? That's a negative value. Log E 0.7 is a negative number. Okay, log E 0.7 is a negative number. Log E 0.7 is less than 0. If you don't believe me, you can put in the calculator and have a look. But it's definitely a negative number. Because it's less than 1, that number less than 1 is below the x-axis. So the y value is negative. So you actually divide a negative value. So that is the most difficult things for this type of question. When you divide a number and you will think, oh, there's no negative sign and it's positive and I don't need to change the sign. And that's the place where you make mistake. So you will have greater or equals to for the sign here because you divide a negative number. You divide by a negative number. And just let's keep looking at this. What's this? What's this? They have the same base and they divide each other. They have the same base and they divide each other. I can say that's log 0.7 and 0.3. I can say that's log 0.7 and 0.3. Use change of base formula. Okay, change of base formula. I use for the reverse way. Okay, for the reverse way. So 0.7 will be the base, and then 0.3. Okay, minus x is greater or equals to log 0.7, 0.3 minus 1. And x will be smaller or equals to negative log 0.7, 0.3 plus 1. Okay, this question is very, very important. Okay, very, very important. You need to know, like, there are a lot of like traps in between. Like, say, first place is you need to log E both sides or log base 10 both sides, just log base 2 both sides. Like, you need a number which I need a base to be greater than 1. If you put a base less than 1, let's say log base 0.7 on both sides, you need to swap the sign. Okay, you need to swap the sign. Because log E 0.7 is a decreasing graph. The larger the x value, the smaller the y value. So if that left-hand side is smaller than right-hand side, and then if you log 0.7 on both sides, the left-hand side will be greater than the left-hand side. Okay, so do not change it so early. Just use a base greater than 1. And then follow this calculations, and you divide by log E 0.7, you should realize log E 0.7 is a number less than 0, and you need to swap your sign. And you minus the 1, and you realize you negative 1 both sides, and you swap the sign again. Okay. This is very, very important. Okay, you need to definitely do that again. So for this exercise 5G is basically to talk about how to solve equations and inequalities for exponential functions. Okay, for exponential function. And let's have a look at the last page. The last page is finding inverse. Okay, the last page is finding inverse. So find the inverse of each of the following and sketch both equations and state the domain and range. Okay, let's sketch log y equals to 10 to the power of 2x minus 1. Let's sketch for that. Okay, first we have where is the, like to sketch exponential functions, like this, all the steps, where is the asymptotes for this one? -1. Okay, we have -1 as the asymptotes. Okay, that's y equals to -1. And have to think about the shape of this graph. The base is greater than 1, so you will have an increasing graph. There's no reflection in the y-axis, there's no reflection in the x-axis, therefore the graph just looks like that. And I always have a y-intercept, so I will say when x equals to 0. Okay, there's always y-intercept. There's always y-intercept. My x can always be 0. So when x equals to 0, y equals to 10 to the power of 0 minus 1. 1 minus 1 equals to 0. I have 0, 0 as my base. Okay, 0, 0 as my base. Okay, and I need to find another point. When x equals to a half. When x equals to a half. Y equals to 10 to the power of 1 minus 1. Y equals to 9. I have another point is a half and 9. Well, it's a really high value. It's not really to scale, but something like that. And the graph will be like this. Okay, the graph will be like that. This point is a half, 9. That point is 0, 0. And y equals to -1 is the asymptotes. Okay, without finding the equations, let's have a think. What will be the asymptotes for the inverse function? If I have y equals to -1, what will be the inverse? X equals to -1. Okay, it's totally opposite. I will have x equals to -1 as the asymptotes. Okay, next thing is, if I have 0, 0 to be the point on the original function, what will be the point on the inverse? 0, 0, you still have that point. If I have a half 9 on the original, what will be the point on the inverse? 9.5. And if it's a exponential function, what will be the inverse? Inverse of exponential is log. Okay, exponential and logarithm is the inverse function. So your graph is definitely should looks like that. Okay, your graph definitely you shouldn't touch here. Okay, something like that. You touch at the point 0, 0. Okay, touch at the point 0, 0. And there's no other point of intersections. So this will have a half, also have 0, 0, and this will be x equals to -1. That's reflected by the line y equals to x. Okay, that's reflected by the line y equals to x. Okay, a graph like that. So let's find the inverse. Let's find the inverse. So change. Okay, so find inverse as I said before. So step number 1, state domain for the function f. So domain of the function f will be R. Okay, for this exponential, let's say fx equals to 10 to x minus 1. So the domain for this exponential is R. Number 2, range for this f. What's the range for the exponential? What's the range for the exponential? -1 to infinity. Okay, see the blue graph is -1 above. Step number 3 is change the xy positions. X equals to 10 to the power of 2y minus 1. Number 4 is rearrange it to make y to be the subject. So x plus 1 equals to 10 to the power of 2y. 2y will be log base 10 x plus 1. Y will be a half log 10 x plus 1. Number 5, the domain for f inverse will be the range of f will be -1 to infinity. Number 6 is the domain of f will be f inverse will range of f inverse will be the domain of f. Domain of f is R, then the range of f inverse is R as well. Okay, another thing is when you sketch 2 graphs or more than 2 graphs on the same set of x-axis, you need to label the graph. Even though you sketch 2 correct graphs, you don't know which one is which one. Okay, which one is the logarithm, which one is the exponential. You definitely need to label the graph. Okay, always remember, even though the question doesn't ask you to label them, you need to label them. You don't know how picky like the VCA examiners are. Okay, they really pick those small points and you lose marks because of that. There are a lot of points you can lose half mark, half mark, half mark, and then finally they round down like to a whole number. So if you not label that, you can lose half marks. Okay, so you will have, this is, let's say we say that's fx and the red one is f inverse x. You need to tell people which one you're trying to sketch. Okay, that's example 1. Have a look at example 2. Example 2, you have log is 3 minus x plus 2. And you want to sketch for this one. Okay, if you want to sketch for this, first we need to find asymptotes. What's the asymptotes for this log function? How do we find asymptotes for log? Is the thing in the bracket equals to 0. You solve for x. X equals to 3 will be the asymptotes. x equals to minus 3. Positive 3, not minus 3. X equals to positive 3. And then we'll think about the shape of this graph. The base shape is log e. So the base shape is like that. But you have a negative sign in front of x. You will reflect by y-axis. Okay, y-axis. Therefore, graph will be like that. Graph will be like the red one. Okay, reflect by the y-axis. So therefore, your graph will be like that. Okay, graph will be like that. But let's find when x equals to 0. When x equals to 0, y equals to log e 3 plus 2. Well, you don't really know what is it, but you know it's a positive number. Okay, you know it's a positive number. Let's say the point is here. And I want to solve for when y equals to 0. There's a y-intercept. When y equals to 0, log e 3 minus x equals to negative 2. 3 minus x equals to log e minus 2. 3 minus log e minus 2 equals to x. Wait. It's not correct. It's not correct. It's not. You don't have negative values. Wait, it's not correct. Let's have a think about the shape. So you have minus numbers, and you have log e positive 2. And the shape will be like that. Okay, base E is like that. X equals to positive 3 is asymptotes. And you will get reflected by the y-axis. It will be in this way. You will have that. Okay, you have log e. Okay, so you are when y equals to 0. Okay, wrong calculations. Log e 3 minus x equals to minus 2. And then 3 minus x will equal to e to the power of negative 2, not log e. And 3 minus e to the power of negative 2 equals to x. So x equals to 3 minus 1 over e to the power of 2. And if I sketch the graph, some shape like that. So this point will be 0, log e 3 plus 2. And that point will be 3 minus 1 over e to the power of 2, 0. And there's also an interesting point here. I always want to find an interesting point is I want to make the bracket to become 1. I want to make the bracket to become 1. So when x equals to 2 is log e1, right? Log e1. Log e1 is 0. Okay, because why I want 1? Because 1 will give log become 0. So when x equals to 2, log e1 is 0. 0 plus 2 is 2. So you have another point at 2, 2 as well. This is like on purpose. I want to make the bracket to become 1, which I know x equals to 2. Well, x equals to 2, and I can find y equals to 2. Which, like, because log e 3 plus 2, you don't know what the exact value is. 3 minus 1 over e to the power of 2, you don't know what the exact value is. I want to find a point which I can really sketch it correctly on the graph, which is 2, 2. Okay, when I know 2, 2, let's have a think about the inverse. Let's have a think about the inverse. So you have a graph, x equals to 3. Then you have y equals to 3. Have y equals to 3. And if you have the point 2, 2, you will still have this point 2, 2 here. You still have the point 2, 2. And you have 0 log e 3 plus 2. Then you have log e 3 plus 2, 0. Okay, let's have a look at how large is that value approximately. Okay, it's more than 3. This number is more than 3. This number is more than 3. Therefore, we will have, well, I shouldn't have this asymptotes here. I will have this asymptotes below. Okay, this point is a number a little bit greater than 3. Therefore, I will have my asymptotes here. Okay, below it. Okay, below it. There is y equals to 3. And I have a number, this number is beyond 3. Therefore, my x as intercept will be here. My x-intercept will be here, like over 3, over the, like to the right-hand side of x equals to 3. And then we have 3 minus 1 over e to the power e to the power of 2 comma 0. You have 0 e minus 1 over e to the power of 2, which I will have the point here. Okay, I will have the point here. Because it's an exponential function, therefore this exponential will look like that. Okay, that's the exponential function. Okay, I will have the point, this point is 0, 3 minus 1 over e to the power of 2. I will have this point as log e3 plus 2, 0. And this point is 2, 2 as well. You have y equals to 3 as the horizontal asymptotes. Okay, if you say that's fx, then first domain of f will be, okay, is the red graph, is negative infinity 2, 3. That's the domain. Number 2, range of f. Range for logarithm function is always R. Okay, range for all the logarithm function will be R. And have a look at the red graph. Okay, it's going upwards. Okay, going upwards. So it's R. Number 3, change x and y. X equals to log e 3 minus y plus 2. X minus 2 equals to log e 3 minus y. 3 minus y equals to e to the power of x minus 2. Y will be minus e to the power of x minus 2 plus 3. Okay, therefore you have y equals to 3 as the asymptotes. Number 4, domain of f inverse is the range of f, which will be R. Number 5, range of f inverse will be domain of f is negative infinity to 3. Okay. That's all the revision for exponential functions. Nothing new compared to last year. Okay, nothing new compared to last year. You just have know how to sketch both graphs, know how to solve equations, solve inequalities. Okay, that's the basic skill for exponential and logarithm. Nothing too difficult for this chapter. Okay, nothing too difficult for this chapter.